Hello researchers and PTI customers and anybody else who's interested in this tutorial. I'd like to show you how to enable what we call a rapid temperature controller. This is a Peltier device that surrounds the sample, and it uses a thermoelectric element to heat and cool the sample so that we can do temperature ramp experiments, or we may just want to regulate the temperature to a high degree of accuracy when making fluorescence measurements. In order to activate the temperature controller, this can be done from the hardware configuration, and you click on the center here and you'll see active, and then in this case I've chosen the single turret. We also have a 4-position one, but we're going to be using the single position turret. I've left it at the default values with the maximum temperature rate. That's 10 degrees per minute. And the stability is set to 1 degree. So I'll be happy if the temperature controller is within 1 degree of range. This can be reduced, but it may require a little extra time for the temperature to reach an equilibrium. So this gives us a little bit of play within 1 degree. And of course there's a timeout here as the default values. So this configuration you would then save or give it a new name. You might want to call it Quantum Master with temperature, and once you say OK, the hardware will then initialize and the temperature controller will initialize, and you'll be given a new tab down at the bottom here that will allow you to set the temperature. So I've set the target temperature to 10 degrees C, and I'm going to say go, and that's going to send my Peltier device down to 10 degrees and start to cool the sample. While it does that, I'll then be able to set up a protocol. So to set up an acquisition protocol, click on Setup and go over to the Time-Based tab. And then we can go in and we can type in the acquisition settings. So we'll excite at 290 for tryptophan, and we'll look at 340 emission. And then we'll just leave these temperature values here. We'll leave these at the defaults, and we're going to go over next to our temperature controller. We want to enable it. This is going to turn the device on, and I like to, when it's finished, set it back to 10 degrees C. You could have it hold at the last temperature or just terminate altogether, or go to a specific value when the acquisition is complete. Now in order to do a protein melt, we're going to choose this setting over here, which is called temperature ramp, and we're going to start our ramp at 10 degrees C and we're going to end it at 80 degrees C. And then the ramp speed, I'm going to go at 5 degrees Celsius per minute. Over in the Traces tab, you'll see we have the intensity and the temperature, which will be displayed in a trace. And what we want to do is we want to add a ramp trace. So I'm going to say add, and we're just going to relabel this. I'm going to call it ramp. And for source 1, we need to choose the intensity trace. And the function will be right here. It's called temperature ramp, and source 2 will be temperature sensor itself, and I'm going to put that in a new graph. So now we have our ramp being generated, our raw data trace, and the feedback from the temperature cell itself. Now that's all that really needs to be done here, and if I'm going to repeat this experiment multiple times, I may want to save it as an acquisition, so as a protocol file. So I can go up to the acquisition, I can choose save as, and I can give this a name. Let's call it trip melt 20-80. That tells us it's tryptophan melt going from 20 degrees to 80 degrees. Now I can easily call that back up, and you'll see that it will show up here on the toolbar. So I've got trip melt 20 to 80 and then a standard trip melt. So this is one I'm going to be using, and anytime I launch the system, I can just click on this menu and it'll initialize and it'll prep that experiment. Okay, now that we've got all the parameters set up, we just have to hit start, and the system will then begin to generate a series of traces, and the Peltier device will then go to reach 10 degrees C. Okay, so the experiments begin, and we're going up here. You can see we're collecting our intensity, and we have temperature on this axis, and then down below we have our intensity versus temperature on this axis. So this ramp will continue, and of course it'll take the length of time depending on what the temperature ramp range is that you've set. So I'm going to let this tutorial run, and towards the end of the experiment I'll show you the resultant data. Okay, our temperature ramp is progressing along nicely. You can see we've been sitting for 8 minutes and 53 seconds, and we're about over halfway. You can see that our intensity increased around 50 seconds, which was around 15 degrees, and we had a change in the conformation, and now we've got a gradual decline in the fluorescence intensity as a function of time, which is common. Likely the protein is unfolding and the tryptophans are likely exposed to solvent, which is quenching the fluorescence slightly. So we will check in towards the end of the experiment and we'll see what this trace looks like. Stay tuned. Okay, so it looks like our experiment's completed. It took about almost 14 minutes to do that ramp, and you can see we reached our 80 degrees here. Well, within 1 degree was our delta that we set, and we've got this nice looking curve of intensity versus time. This is the temperature ramp that shows the thermoelectric device, and down here we've got our derived data that shows our intensity as a function of temperature. Okay, so this is what we've done. We've ramped the temperature up, and now what we can do is we can ramp the temperature down. In the next tutorial, I'll show you how to ramp the temperature down.